You ever watch an athlete make some incredible play and just think, how did they do that? That perfect kick, that lightning fast throw, it can look like magic, but it's not. It's pure science. And today, we're going to pull back the curtain on the amazing biological engineering that powers every single move you make. I mean, really think about it for a second. To kick a soccer ball or clear a hurdle, your body has to coordinate this whole symphony of tiny, precise actions all in a split second. So how in the world does it nail that timing and power over and over again? Well, that's what we're here to unpack. The answer starts with understanding the basic science behind it all. So let's dive right in. This whole field has a name. It's called biomechanics. And it's basically the study of how our skeleton, our joints, and our muscles all work together like this one incredible biological machine. It's the how behind every step you take, every time you stretch, and every time you sprint. And you can really boil this whole complex system down to 3 key players. First up, you've got your bones. They're like the frame or the scaffolding of your body. Then you have the joints. Think of them as the hinges that let everything move. And finally, the muscles. Well, they're the engine, providing all the power to get things going. And trust me, this is no simple machine we're talking about. Your skeleton alone is made up of more than 200 bones, all working together in perfect sync. I mean, just think about that. That is an incredible number of parts to coordinate for even the simplest little movement. Okay, so let's zoom in a little bit on those crucial connection points, the joints. How do they manage to move so smoothly day in and day out without just, wearing out? So here's a huge engineering puzzle the body had to solve, right? Bones are super strong, but if they were just grinding against each other all the time, they would wear down to nothing. So our bodies came up with this brilliant multi-part solution to stop that from happening. Part 1 of that solution is this amazing material called cartilage. The best way to think of it is like a super tough, super slippery coating right on the ends of your bones. It's like the body's own built-in shock absorber and friction reducer all in one. But it doesn't stop there. The body adds another layer of protection. Our joints are actually bathed in this special lubricant called synovial fluid. It's basically high-performance oil for your biological machine, making sure you get that effortless, gliding motion every time you bend your knee or your elbow. Okay, so you've got these slick, cushioned bones. But what's stopping them from just falling apart? Well, that's where ligaments come in. These things are like incredibly strong, slightly stretchy straps that connect one bone to another, making sure the joint stays stable and secure. And the final piece of this joint puzzle is the tendon. Tendons are the absolutely critical link between your muscles and your bones. So when a muscle contracts, it pulls on the tendon, and the tendon then pulls on the bone, and bam, that's how we get movement. So we know what a joint is made of, but how they're built actually determines the ways we can move. Let's take a look at the 3 main designs the body uses. We're going to focus on the 3 main types of these synovial joints. They're the most common, and they give us the biggest range of motion. We've got hinge joints, pivot joints, and the famous ball and socket joints. First up are the hinge joints, and honestly, the name pretty much says it all. They work just like a hinge on a door, letting you move back and forth in 2 directions. Your elbows and your knees, they are perfect examples of a hinge joint. Next up, we have pivot joints, and these guys are all about rotation. You've got one in your neck that lets you turn your head side to side, and another great one is in your forearm. Go on, try it right now. Hold your arm out and just turn your palm up and then down. That turning motion, that's a pivot joint at work. And finally, we get to the champions of mobility, the ball and socket joints. You find these in your hips and your shoulders. Basically, the ball at the end of one bone fits into the cup-like socket of another, and that design gives you the absolute greatest range of motion in pretty much all directions. All right, we've talked about the frame and the hinges. Now it's time to talk about the engine. Let's get into the fascinating way our muscles actually generate all that force. Now, here is maybe the single most important thing to understand about how muscles work, and it's a little bit weird. There's a golden rule. Muscles can only pull. They can't ever push. Seriously. So think about that. If a muscle can only pull your arm up, how in the heck do you move it back down? Well, here's the body's super clever solution. It arranges muscles in pairs. They're called antagonistic muscles, and they basically work in opposition to each other.
So as one muscle contracts and pulls, its partner on the other side of the joint has to relax and stretch out. Let's use your upper arm. It's the perfect example. To raise your forearm, to make a muscle, your biceps on the front contracts. It pulls. At that exact same moment, its partner, the triceps on the back of your arm, has to relax and let go to allow that movement to happen.
And then, when you want to lower your forearm, the whole thing just flips perfectly. Your biceps relaxes, and now it's the triceps' turn to contract and pull the arm back down. It is this beautiful, coordinated dance that gives us controlled movement in both directions. Okay, so we've looked at all the nuts and bolts, but why does any of this actually matter to you in your daily life? Let's bring it all home and see this stuff in action. This is where it all pays off. By studying biomechanics, athletes can fine-tune their movements to get a serious competitive edge. And it's also absolutely crucial for preventing and treating common sports injuries, like damage to those very important ligaments and tendons we were just talking about. And if you're still not totally blown away by the power of this system, get this. While it's kind of tricky to compare all the different muscles, a lot of scientists believe that the muscle that can apply the greatest force in your entire body is the one in your jaw. Just amazing, isn't it? So the next time you go for a walk or run or even just pick something up, maybe take a second to appreciate the incredible silent science that's at work. Your bones, your joints, your muscles, they're all performing a little miracle of biomechanics. It kind of makes you wonder, what everyday miracle will your body perform next?